Alrighty, so we're going to talk about Matter Notes Part 3, separating mixtures. You'll definitely have a quiz or test question or both coming up on this kind of stuff. So just remember, you don't have to write down everything I have on my smartboard, but you do want to make sure you understand the things I have read or highlighted, that kind of thing, the things that I emphasize. So let's not forget from last week, mixtures are not chemically bonded. They're not chemically bonded. And so we should be able to separate them by physical means. So what I'm saying is, when you have a mixture, the things in the mixture are not chemically bonded to each other. So when you separate them, you shouldn't be changing anything chemically. Like you should have the same two things, they're just now in different containers. Okay, so salt and water are not chemically bonded. So if you were to separate them somehow, you should have salt and water still. They're just in two different containers. So separation techniques are physical means of separating things that are not chemically bonded. Okay. Now to separate things, you need to utilize different properties of the materials in the mixture. This is a big idea, okay? Lots of stars going around this. You need to find what is different about the chemicals in the mixture. You need to find what is different. That is the key idea. You're going to find out what's different, and you're going to use that to your advantage. So some things that may be different between two different chemicals in a mixture. They may have different boiling points. They could have different densities. They could have different solubilities. The point is you need to find something that is different about two things and use that to your advantage. You're going to take advantage of that. Now to say the same thing on the other side of the coin, when chemicals are really similar, they have really similar properties, they're more difficult to separate. Okay? Similar are difficult to separate. Kind of like twins. So for example, if I had some twins here, so I googled twins and it's like one of the first pictures that came up. Okay, so let's say I had two guys here. We'll call them, we'll call them Jerry and Larry. Okay? And let's say I wanted to separate them. I wanted to get one to go to the left side of the room and one to go to the right side of the room. Okay? It's hard to do that when they're twins. So for example, if I'm like, all right, if you have curly hair, go to the left side of the, oh wait, you both have curly hair. Well, okay, how about if you have a beard, go to, if you have a blue shirt on, why don't you go to the right? Okay. Well, wait, how am I supposed to separate these guys? They're so similar. How do I separate them? Oh, if your name starts with a J, go to the left side of the room. If your name starts with an L, go to the right side. So I found out what is different about Jerry and Larry, their names, and I took advantage of that fact. Okay? So you need to find out what is different about things in a mixture, and you're going to use that to your advantage to separate things. Okay, I separated Jerry and Larry because they had different names. I wasn't able to separate them based on the things that were similar, like their curly hair and their beards and their blue shirts, but what was different. Okay, so let's talk about different methods. These aren't all the methods in the world to separate things, but there are a few of the heavy hitters that we'll talk about here in class. First up, we have distillation. Distillation. So distillation is when you separate things by their different boiling points. When you separate things by their different boiling points. So what you do is you heat the substance until whatever has the lowest boiling point evaporates away. Whatever has the lowest boiling point evaporates away. So that's distillation. It separates things by their difference in boiling points. The next one we got is filtration. Filtration. This is when you use a filter. Okay? Filtration, it separates things by solubility. So when things have a difference in solubility, you use filtration. Filtration. Okay? And remember, solubility is when something can dissolve in water. So if something can dissolve, okay, it's soluble. So filtration works. It works with soluble versus insoluble. So filters can remove or collect insoluble solids in a solution. Insoluble solids in a solution. So we're going to go ahead and do an example of that now too. All right. So right here, I'm going to make a mixture. So I have some water, just plain old water in the faucet. Okay, food coloring. Is food coloring soluble or insoluble in water? It's soluble, okay, because you can mix it in and it can dissolve in water. So if I put 1 drop of food coloring in here, doink, got some purple, stir it around. There we go. So food coloring is soluble because it can't dissolve in water. Okay, so we're going to create a mixture like I said. Get the cap on there. Plastic beads. Are plastic beads soluble or insoluble in water? Insoluble. So if I pour these in here, even if I mix this up, the beads just won't dissolve. Okay, they're insoluble. So that means that a great way to separate the food coloring and the beads could be with a filter. So here's how that works. Here's what a filter looks like. It's like a pizza pie, a little circular piece of paper. Imagine they just dissolved. Huh? So what you do is you fold this in half. Amazing. Oh my God. And then you fold it in half again. So now you got 1/4 of a pizza pie. Looks like a slice. And you open up one of the slots. And you get like a little snow cone looking thing. Whenever I make you guys do this lab, if we get to do this lab, you'll be amazed at how this is really confusing for folks. Because it looks so simple, but like a lot of people are like, wait, how does it? Anyways, so you get the filter paper like this, little cone. Now, what you'll do is you'll take that filter paper and you'll put it into a funnel. I get it a little bit wet so that way it gets stuck to the sides of the funnel. Okay, something like this. So that way, when you turn this upside down, it's like stuck in there. Okay, so there's a funnel stuck in that, or the filter paper stuck in there. I'll put it on an Erlenmeyer flask. And if I pour this through the filter, there we go. So look what happened. The soluble food coloring went through the filter, but the insoluble beads got stuck in the filter. See that? Okay? So I was able to separate them like that. Now, this technique doesn't really work well for separating water and food coloring because food coloring is soluble in water, but it can separate the beads in the water because beads are insoluble. So that's that for filtering. Filters, they're great for large quantities because you can, like, if you want to filter like 500 gallons of something, like all you have to do is just get a big funnel and like some sort of filter and you just pour whatever it is through it. Like it's really good for large quantities. People use this in industry all the time. It's really easy. So filters are good for big stuff. Okay. So now that brings us to the centrifuge. The centrifuge. Okay. Centrifuge is good because it separates things by density and solubility. So it's a little bit of a mixture of both. Filters are only good for things if they have a difference in solubility. Centrifuge, you need that difference in solubility, but you also need to separate them by density. Okay. So centrifuge, it only works to collect insoluble solids in solution. So something still has to be insoluble, but maybe you have a couple of insoluble solids in there, and you want to separate them based on their density. A centrifuge is good for that. Okay, now let's see here. Mr. Williams, you got shoulder problems? Mm-hmm. You have any shoulder problems?
No.
Okay, you're going to be my volunteer for something. So what I'm going to have you do, Mr. Williams is going to go like this. I'm going to have him stand in the front of the room, and he's going to swing his arm around as fast as he can. Okay?
Oh, no.
So what you're going to do is you'll come up here. You're going to stand in front of Melania here. You're going to swing your arm as fast as you can. You're in this lane, so you don't smash your hand on the table. Okay? Makes sense? Okay. And then when I say stop after about 10 seconds, 9 of which you will really not like because it's just super, it doesn't feel great. When I say stop, you're going to go to this, like this, in front of Melania. You're going to show her both of your hands. And you are going to tell us what you see. Okay? That's it. All right. Are you ready, Mr. Williams? Again, make sure you do not hit a disc. And you're gonna let her rip for like 10 seconds. Okay? You ready? Let her go! Keep her going. Faster! Faster, Mr. Williams. Your grade depends on it. Keep her going. He's swinging his arm around. He looks really smart right now. Keep her going, Williams! Yeah, yes. All right, show Melania your hands. Hold them both out to Melania. Melania, what do you see? Melania says one is way more red. Which one is it? The one he was swinging. Great. Thank you, Mr. Williams. Mr. Williams swung his arm around, and the arm that he was swinging around, his hand became way more red. Okay? Way more red. What you just did did you feel little pinpricks in your fingertips? Mm-hmm. Yeah, super annoying, right? I used to do that myself, but then my arm got really sore after I did that for 5 periods, so I was like, nah. So I'll make my students do it. But anyways, you just centrifuged the blood in your arm. That's what you just did, okay? So what a centrifuge does is it spins crazy fast, okay? The insoluble and the more dense particles settle to the bottom of the container. Mr. Williams, in a sense, that was his fingertips, okay? All the blood was settling to the bottom of his container, his arm, his fingertips. So, I got a demonstration for that one too. I actually have a centrifuge. Now, virtual people, you won't be able to see the centrifuge itself. That's going to be off screen. But it's a big machine that spins the crap out of stuff. Now, here I have some sodium hydroxide and some magnesium sulfate. Okay? Now I'm going to pour these 2 samples together, and I want you to watch what happens. Okay, it made a white powder. So this was probably a physical or chemical change. Chemical change, because a new substance formed. Hey, what do we call it when a solid forms like that? It does start with a P. Precipitate. It's a precipitate. So we made magnesium hydroxide precipitate. Let's say we want to separate this from the remaining sodium sulfate. Okay? Here's what you can do. You can take a centrifuge tube. Here's what they look like. It's a pointy looking test tube looking thing. Pour some of my sample in there. Okay? Now, centrifuges kind of work like a seesaw where you have to have them balanced out. Okay? Otherwise they'll break. So what you got to do is, you got to get another tube to put on the opposite side. That's filled up about the same amount. Okay? So this is just water. This is just for balance. Just for balance. Okay. So if I come over here, see there's a bunch of slots there for test tubes. Okay? So I'm going to put these 2 on opposite sides. Boom. Close it. Lock it. Turn on a timer. And now it's going to start spinning. Maybe. Spin you! Oh. There we go. Okay. Now this is where we spike up those patience hands, and we just got to wait for like 30 seconds. Here we go. So if I find my sample, as you can see, all the magnesium hydroxide got flung to the bottom and stuck down there to that powder, whereas the sodium sulfate is on top. So you virtual folks, see how it's all stuck on the bottom? It's a little bit angled there. If I pour this off, okay, now I just have magnesium hydroxide stuck in there and I have them nice and separate. Okay, so that's the centrifuge. 2 things have to be true. 1, there has to be some sort of insoluble solid. Okay, so magnesium hydroxide, if it formed as a precipitate by definition, it is insoluble. And 2, has to be a difference in density. Okay? So if it's more dense, it gets flung to the bottom of the test tube. So magnesium hydroxide in this case is more dense. And that's how we can separate mixtures that way. So that's the centrifuge. It only works well for small quantities, but it is super fast. Sometimes filters can take a really long time. Especially when the filter gets more and more full, it takes longer for stuff to go through it. A centrifuge is really fast, but you can only do a really small amount of stuff in it at a time. Like it takes kind of forever. Okay, so we're going to get to chromatography. That's our next one. But here's what I want you live students to do. You're going to real quick, you're going to grab a paper towel. Okay? You're going to go like this. You're going to take your paper towel. Doesn't matter about how big. You're going to fold it a couple times. So you get like a little paper towel pillow. Just kind of fold over so it's nice and flat like that. So go grab one real quick and bring it back to your desk. So we're getting paper towel pillows. Paper towel pillows. It's going to be a good time. Just get it nice and flat. A nice flat little paper towel pillow. Does not have to be perfect. Obviously, the size doesn't really matter that much. It's a little baby one.
Yeah.
All right. So let's talk about chromatography real quick, and then we're going to talk about what the deal with the paper towel is. Chromatography separates mixtures of colored chemicals. So, for example, a marker, okay? So substances that dissolve easily will travel the farthest up the paper, the solid material. So here's our marker from earlier. Look how wet this paper is. So you see how it carried all the colors all the way up. So it looks like pink was the most, or the least soluble because it went the least far up the paper. The green and blue that were in that gray marker got carried all the way up to the top where the paper ended, and these would have kept going if they had the chance. Okay? So you see how we separated these colors? Okay? Here's what other colors of Crayola markers will look like. Black is on your left, brown is on the right. So if you look at these, black has got blue and orange and pink in it. So that's how chromatography works. It separates things based on differences in color. Okay? So again, the ones at the bottom, so orange in this case is probably the least soluble in water, whereas like this blue up here is the most soluble in water. And that's why it traveled the farthest with the water up there. Okay? All right. So now what I'm going to do is I'm going to go ahead and I'm going to go around the room with a pipette. I'm going back to the distillation step, so still listen to me, virtual folks, you just won't be able to see me. Okay, here's what I'm going to do. I got the distillation beaker over here. So you'll notice I have some sample. This came out of the peach pop. Look at that. It's clear. Interesting. So I'm going to go ahead and put a little bit of this on each of your little paper towel pillows. You just look at flat there. And, let's try. There we go. Just leave your paper towel pillow there for a second so I tell you what to do. There we go. Yep. Oh, it's just peach pop stuff. There you go. She's like, no, there's a wet spot on my desk. There we go. Here we go. So I'll tell you guys what we're going to do with this in a second. There we go. We're going to let it soak into the paper towel. If you get a little bit on your finger, don't worry. It's, again, this came out of the peach pop. It can't really be that bad for you, huh? But peach pop is really sus. Boom. Normally I'll let you guys just pass this beaker around, but we can't really do that right now. Okay, because of COVID. Okay, so check it out, virtual folks. This came out of the distillation. It's clear. What are some things that this definitely tells us? That the food coloring, right, is, oh, I should take it off. The food coloring is stuck behind, because that stuff is all clear. So what does that tell you about the food coloring? The food coloring's boiling point must be higher than whatever stuff came over here. Does that make sense? Okay? Now, what I want you guys to do, you'll really briefly, very briefly, you'll do one of these with your paper towel. You'll go like this. Get a good whiff, and put the mask back on. Go ahead and do that. They're smelling their paper towels. Mooney loved it. She loved it. What does it smell like?
It smells like peach and like.
You smell the peachy flavor a little bit? Couldn't smell it? Weird. I'm getting the peachy smell a little bit.
You got the whole thing.
I know. It was easier for me, but so what happened was the peach flavoring, whatever it is, that ended up in the beaker at the end of the distillation, whereas the food coloring stayed behind. So what does that tell you about the food coloring versus the peachy flavor?
They have different ones.
They have different boiling points. Which one's higher?
The
color.
The color must be higher because it didn't evaporate yet. The peach flavoring did, and that's why it ended up in the other container. So even though this is clear, this is nice and peachy smelling. Okay? So That was those paper towels. Now let's go ahead and let's go back to the cereal and water that we've had over here. So hopefully you guys can see that. There you go. It's still spinning. I'm going to go ahead and turn the spinner off. Oh, yeah. Oh, that's the good stuff. Oh, yeah. There we go. Okay. So now I got the magnet from before. You virtual folks, take a look at that. See that on the end of the magnet? Okay. So on the end of this magnet, it looks like it grew some hair. It's actually some iron. These are iron, yeah, they look like iron shavings. See, that's what they are. So this came out of the cereal. These are like little things of iron. See that stuck on the magnet there? So that came out of that cereal, which I just made mushy with water.
What could you have done with milk?
Huh?
What could you have done with milk instead of water?
I didn't have nothing. Milk would get all gross and stuff during the day. See that iron? Iron on the end there? So total cereal really does have iron in it. And I manipulated the fact that iron is magnetic and a bunch of the other stuff in there is not. So I use a magnet to get the iron out. See that? So there you go. There's some proof in the pudding for you. Also, I love to do this. And then someone's like, that looks like dog threw up. You can see my sink right now. It looks disgusting. Anyways, I don't wanna. So we got 5 minutes left. Go ahead and knock out your 3-question lecture quiz. And then virtual folks, once you guys do that, hey, it was nasty, McDaniels. Virtual folks, once you take care of that 3-question quiz, you can go ahead and get on out of here. So I'll see you guys later. Go ahead and take that quiz.